This is a continuation of section 12.5 in honors geometry, where we're finding the volume of pyramids and cones, and we're going to start off by finding the volume of this frustum. Now, if you recall from the surface area problems, what we want to do is extend the two lateral edges until they meet at a point, because basically what a frustum is a cone that had the top part of it chopped off, and what you have left over then is the frustum that we're dealing with. So we're going to approach it from that standpoint. I'm going to draw in the height of the entire cone, draw in the radius of the top small cone, the radius of the bottom big cone, and then I can notice that we do have some similar triangles in this scenario. So I'll draw out that scenario, just the cross section with those triangles, and 5 is the slant height of the frustum, 12 is the diameter of the bottom of this, so 6 is the radius, 4 is the upper radius, and I'll create a temporary variable of x, which stands for the slant height of that top cone that was chopped off. Now, using similar triangles and proportions, we could say that 4 over 6 is equal to x over x plus 5. It's not just x over 5. If we did it that way, it'd be incorrect, because the two sides that are parallel, the 4 and the 6, are in this proportion. We have to use the entire sides of the triangle. Now, as we continue solving this, and we'll cross multiply, 4x plus 20 is equal to 6x. Subtract 4x from both sides and then divide by 2. So now we know that x equals 10. So redrawing this triangle again, we have 10, 5, 4, and 6. We need to know what is the height of that small triangle and what is the height of the big triangle. I'll use the temporary variables of h and y. Now, for the small triangle, we can use Pythagorean theorem. Specifically, 4 squared plus h squared is equal to 10 squared. Subtract 4 squared from both sides, you get h squared is equal to 84. Take the square root of that, h is equal to 2 root 21. We're going to do the same thing for the big triangle. So not just that little turquoise one now, we're going to look at this entire green triangle. And again, it's a right triangle, Pythagorean theorem, so we could say that 6 squared plus y squared is equal to 15 squared. Cross multiply and solve, or simplifying this one. So y squared equals 225 minus 36. Subtract those values from each other, and we get that y squared equals 189. That can be simplified also down to 3 root 21. So we have all the numbers we need. Now it's just a matter of putting it together. So the volume of this frustum is equal to the volume of the big cone before anything was chopped away minus the volume of the small cone that was actually chopped off. The volume of the big cone, 1/3 pi times the radius squared times the height, minus for the small cone, 1/3 times pi times the radius of 4 squared times its height. Now we can use some algebra to simplify this down a little bit. For the first part, 1/3 times 36 is 12. 12 times 3 is 36. So this is 36 root 21 pi minus 4 squared is 16. 16 times 2 is 32. Divided by 3, we get 32 pi root 21 all over 3. And now when we combine those together, we're taking 36 minus 32 over 3. And then we want looking for a common denominator. That's going to give us 76 pi root 21 over 3. And then if we simplify that answer, we're going to get approximately 364.71 units cubed. We'll look at one more frustum problem. Different numbers, but we again have a frustum. I have the top diameter, the bottom diameter, and now 10 represents the perpendicular height. Process is the same. We're going to extend those lateral edges so we get the initial cone that was in there. We'll draw on the entire height, a radius and a radius. We have the similar triangles, and we'll focus on those similar triangles. This length is 10, 4, and 7 with a bunch of right angles in there. What we don't know is this length of x. So we could set up the proportion as x over x plus 10 is equal to 4 over 7. Cross multiply. 7x is equal to 4x plus 40. Subtract 4x from both sides. and then divide by 3, so x equals 40 over 3. Now we're going to go straight to finding the volume because we have all the information we need. The volume of this frustum is equal to the volume of the big cone minus the volume of the small cone that was chopped off again. For the big cone, we have 1/3 times pi times the radius of 7 squared times the height. The height is going to be 10 plus x. So if we take 10 plus 40 over 3, get a common denominator, that's going to be 70/3. Minus, now for the little one, 1/3 times pi times the radius of 4 squared times the height, which is 40/3. Now we're going to look to simplify this a little bit. I have 3,430 pi over 9 minus 640 pi over 9. And if we subtract those, combine and simplify it, it comes out to 310 pi, which is approximately 973.89 units cubed.